Hi guys, so we're going to talk about the opposite of what we talked about on page 23. So the big thing about all four of these flippers that we have here on this foldable is that the angles had to be formed by parallel lines. If we didn't have parallel lines, then none of these things would be true. So today, what we're going to talk about is if we have corresponding angles that are congruent, then we're going to have parallel lines. If we have alternate interior angles and they're congruent, then we have parallel lines. So we're going to look at a set of lines and we're going to decide whether or not they are parallel. So that's what this box up here at the top of this paper is talking about. Today we're going to identify whether or not we have parallel lines. It says, if two lines in a plane are cut by a transversal and certain conditions are met, then the lines must be parallel. Okay? So we're just going to say, are they parallel or not? Yes or no. And they're all the things that we talked about last time. If corresponding angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. If consecutive interior angles are supplementary, meaning they add to 180, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. And this last one here, if two lines are perpendicular to the same line, then the lines are parallel also. So let's look at example 1. It says, given that angle 1 is congruent to angle 3. Is it possible for these lines, for any of these two lines to be parallel? So what do we think, what kind of angles do we think angles 1 and angle 3 are? Well, if we think about maybe line A and line B being our parallel lines, then angle 1 and angle 3 would be called corresponding. So angle 1 and angle 3 are corresponding and congruent. So line A is parallel to line B. Now remember, we can say parallel using this two line right here. That means parallel. I don't like to write the word out. So that means parallel. Okay? Does that make sense? So this is a way to, it's a symbol for parallel. Alright. So that's all you do. If it says, is it possible for them to be parallel? If so, justify your reasoning, state the postulate. Well, we need to say 1 and 3 are corresponding and congruent, so line A is parallel to line B, and we can say this is by the corresponding angles postulate. And it's not actually by the corresponding angles postulate, it's by the converse of the corresponding angles postulate. Remember, we're going backwards. Excuse me, we're going backwards. The original thing we said was, if they're parallel, then corresponding angles are congruent. But now we're saying, if corresponding angles are congruent, then they're parallel. So we're doing the converse, we're flipping them around. Okay, so let's look at example 2. Example 2 says, if the measure of angle 1 is 103 degrees, and the measure of angle 4 is 100 degrees, is it possible to say that any two lines are parallel? So if we pretend line B is not here, and I'm even going to just go ahead and white it out to show you for video purposes. If we pretend it's not here, see if it's gone, then we have two lines cut by a transversal. So the two lines that we think might be parallel are this top line and this bottom line. Now obviously you can't white out that middle line, but you can look here and see, and then imagine that line being gone on your paper. Okay, so what kind of angles are these? That says 100 degrees, not 1,000. Okay, what kind of angles are these? They're alternate interior angles. So angle 1 and angle 4 are alternate interior angles. They are not congruent, and we can abbreviate congruent with our congruent symbol. So what can we say about lines A and C? So we say, so lines A and C are not parallel. They're not congruent, so lines A and C are not parallel. Okay? So if this was 100 and this was 100, then we would say, yeah, those two lines are parallel. Or if they were both 103, then we would say that they were parallel. But because angle 1 and angle 4 are not congruent, then those two lines are not parallel. Okay? Alright, so let's look at the inside. There's a couple more examples to look at. Example 3. Example 3 says, given that angle 1 is congruent to angle 5. So angle 1 and angle 5 are congruent. Is it possible to justify that any of the lines are parallel? So we're going to say angle 1 is congruent to angle 5, and what kinds of angles do you think they are? Well, if we erase this middle line right here, can everybody see the two lines that could possibly be the ones we're talking about as maybe parallel? Okay? Angle 1 and angle 5 are what? Corresponding. So, they're corresponding and they're congruent. So what can I say? So, lines L and N are parallel. Okay? Lines L and N are parallel. Okay? Now, yeah, I know you can't white out this middle line, so you're going to have to start trying to think in your head, okay, if I get rid of this line right here, I can see two lines. That's the whole point. Okay? Alright, let's look at number 4. Number 4 says, if the measure of angle 4 is 105, and the measure of angle 5 is 70, is it possible to prove that any two lines are parallel? So, we're probably going to be talking about which two lines? Lines M and lines N. What kind of angles are 4 and 5? They're consecutive interior. Angle 4 and angle 5 are consecutive interior angles. Angle 4 plus angle 5 does not equal 180 degrees. Remember, these are supposed to add to 180. They add to 170. So, line M is not parallel to line N. And maybe I'll write that on the second line to make it a little bit neater. To line N. Okay? So all you're doing is trying to figure out which two lines they're talking about, okay? If they give you more than 2 or more than 3 total lines. Alright? And which one's the parallel and which one's the transversal. It's kind of easy to figure out which one they're talking about as the transversal, because usually the transversal is going to be going the opposite direction than everything else. So if you see the transversal on this one went the opposite direction than any of the other lines, here we've got these guys going the opposite direction. They're cutting through the other lines. So you're looking for the transversal, the one that goes through more than one line. Okay, so 5 and 6 and 7 are essentially finding the value of x so that we have parallel lines. So we're saying that we're going to try to make these parallel. In order to make them parallel, we've got to make sure they follow those specific rules. So if you look, we've got this angle here and this angle here. And what are these angles? Well, here's my transversal, line AB, right? So these are my parallel lines. If those are my parallel lines, or at least the ones I'm trying to make parallel, then what do I know about these angles? What kind of angles are they? They're alternate interior angles, and we know alternate interior angles are congruent. So we're going to set 3x plus 10 equal to 6x minus 20. And then just solve that equation. So you subtract 3x from both sides, and you get 10 equals 3x minus 20. And then you add 20 to both sides, and you get 30 is equal to 3x, and then you divide by 3, and you get x equals 10. Now when you're finished, you need to make sure that actually you solve the question, answer the question that's asked. It's asking you to find the measure of angle ABC. So where is angle ABC? Angle ABC is this angle right here. So that's 6x minus 20. So I'm going to take my 10 and I'm going to say 6 times 10 minus 20, and that's equal to 60 minus 20, which is 40. So the measure of angle ABC is equal to 40 degrees. And that's my final answer. Okay? Alright, number 6. So number 6 is saying that PQ is parallel to MN. So here's PQ and here's MN. Now it's saying we want to know what the measure of the first angle is so that they are parallel. So that means that if I have these two angles here, what kind of angles are they? They are alternate exterior angles, and we want them to be congruent. So that means I'm going to take 11x minus 25 and set it equal to 7x plus 35, and then I'm going to solve. Okay? So subtract 7x from both sides. That gets you 5x, is that right? No, 4x. 11 minus 7 is 4. 4x minus 25 equals 35. Add 25 to both sides, and we get 4x equals 60. Divide by 4, and then x equals 15. Wait, is that supposed to be my answer? No, they said find the value of ZYN. ZYN. Find the value of ZYN. So I take my 15, and I say 7 times 15 plus 35, and that equals 140. So the measure of angle ZYN equals 140. Make sense? Okay. Alright, number 7. Number 7 is the same question. It says find x. Oh, we only have to do one step here. So that GH is parallel to RS. So I'm trying to show that RS and GH are parallel. So to do that, I've got to have those special rules making sense. So we've got 7x minus 3 and 9x minus 21. What kind of angles are those? They cross the transversal, so they're alternate interior angles, and we know they're supposed to be congruent. So 9x minus 21 equals 7x minus 3. Subtract 7x from both sides. 2x minus 21 equals negative 3. And then we're going to add 21 to both sides. And 2x is equal to 18. Divide by that 2. X equals 9. And we are done in this case because we were just trying to find the value of x. Alright, so we are going to glue this in on page, sorry, I don't know what page to glue this in. Hold on just a second. Let me pull up my page and I'll let you know. So this will get glued in on page 25. This gets glued in on page 25. So make sure you glue this to page 25 in your spiral. Thank you so much.